Hello, everyone. Nice to be here. And today I'm going to talk about smart contract indexing on chain. With this EIP, the proposal is to create a root of trust for immutable bytecode, which in my opinion, when I joined the blockchain vibes, was like the big offering of the blockchain, that the bytecode is a rule and it's immutable, you cannot really walk around that. And then I figure out that there are proxies and not really that easy. So how did I get here, and what was the road that brought us to proposing this EIP? Is that we wanted to build apps on chain for smart contracts. We didn't really want to build yet another blockchain. And we faced many challenges there. And one of these challenges was lack of standardized factories. So today, a lot of projects like Aragon, ENS, Safe Wallets, a lot of DeFi protocols will design their own factories to deploy the code. And oftentimes, what you'll need is not just deploy the code, but ensure that you actually have some kind of registry which says you that, hey, this code actually was deployed from a trusted factory. Therefore, you can have some kind of level of interoperability between the apps or between the deployed bytecodes, because you're quite determined that it is performing according to the factory rules. Now, the problem, though, is that all of that is super custom. So every project will have separate implementation, and we were standing basically on this road of choosing, do we also want to write yet another custom implementation of something that can be actually generalized? And the generalization is basically that, yes, you have this like tree of different instantiations of any kind of contracts, which kind of like still have some base layer, the root of this trusted environment. So we actually proposed the ERC-7784 as beginning of that, which is basically the same as 7784, but it's ERC, basically a smart contract, and it has some challenges. So what is it about, actually? So TLDR. Basically, we want to have this GETCONTRACT opcode, which we can feed in the hash of the bytecode and get the address where that functional piece exists on the blockchain without having to think what is an address, because the addresses on chain today, they have account information. They store information about the storages, the accounts, and with that also the bytecode, but we don't need the storages of the accounts. We actually want to have the library. We want to have this beautiful, immutable library of the source code we can refer to. And if we have it, it creates us basically this kind of intent mechanism that I can say when deploying my code that I want to process these calls as if I'm ERC-20 token without thinking about they have to write all of the ERC-20 implementation and deploy it. And it has some nice features. It makes it globally portable, even across chains, immutable, and quite secure. So why did we need that for building apps, and why apps will love it? So few reasons. First of all, it will make deployments cheaper because you will reuse more code from already existing deployments, and the whole Ethereum with that becomes a huge library of interoperable smart contracts where you can refer to others' code and reuse it, not just by compiling in Hard Hat or Foundry and deploying yet another same implementation, but just referring it on chain. And it opens up actual ability. Yesterday it was a nice idea, so I added it to the slides to actually have a precompiled for everyone. So if you actually have index for the bytecode, you can actually as well check how much is being used, how much is gas being spent on that bytecode, and then protocol level developers, well, they can optimize for that, and they can make precompiles for that and optimize retroactively, just seeing on the usage of that particular functional code piece. And then it adds like really nice features for app developers, such as feature flags. So say I want to have compound markets on some chain where it's not deployed yet. And if I have EIP-7784, what I can do is I can say, if there is a distribution of this exact bytecode, which represents compound market as it is today, say on Ethereum, and I know the hash of that, then I automatically whitelist to do some functions on my chain, on my contract, even without it being deployed yet. Or if I'm security auditor, I can attest that some code will be secure on chain even before that code is being published somewhere, which is a nice feature as well. And the biggest offering, of course, is that it enables this trust because it's immutable. You cannot really proxy around the bytecode references. And there is a lot of use cases for that. So here I wrote some. I hope you can see that, actually. I'm not sure if you can. This is like how it could be used for 7702 with the delegations. So instead of delegating to an address, you could write a simple proxy contract which uses 7784, or it could be baked into 7702 as well. But anyway, which would say that you just whitelist the hashes of the functional bytecode that is allowed to operate from your EOA. It makes it very easy because you can whitelist these hashes even if the code is not available or if you don't know the address of that code, but you know exactly functionality. Let's say you compiled it, or you just have a general trust registry or security oracles that whitelist that, and you don't have to think about the accounts today as they are, since you don't have to think of all the storage thing, which are account related, not the bytecode. So, good news, everyone. It's a part of Ethereum distribution system, which I was crazy enough to start writing as this generic solution of the factories and registries. And with having such a mutable thing, which you can safely refer to, it enables actually to have this unified interface for smart contract distribution and save time on repeating factory registry designs. And since it's immutable, well, you can make packages. And not just make packages, but other developers can trust that this package you distribute, it is going to perform same way as it does today, tomorrow, and day after, and year after. And even if you are on a different chain, you still can assume that there is this package existing on another chain, and I can whitelist, and I can package it, and I can port it, and everyone can really easily attest and verify that indeed this package is secure by just checking the bytecode hashes without any account information which is today on Ethereum. So check it out. It's a public repo, EDS, on our GitHub. And it's really cool. It's a little bit hectic to get big projects using that because, again, like a lot of investments are done in these custom factories. But if you are writing some project in that direction, then EDS can actually help you out to save your time. And the structure of EDS is quite big, but in the essence, what we are doing is we are basically setting up few layers of assumptions about entities who do the deployments. We have permissionless domain, where basically you would think of this here as EIP-7784, which acts as a trustless registry for the functional pieces. And then developers could develop the code and it automatically gets indexed. The current implementation of EDS actually uses ERC-7744, which requires developers to manually index that. And yeah, EIP-7784 would really help out by automatically reindexing this. There are a few projects we wrote. The solutions.peeramid.xyz is a safeguards plugin which answers challenges for a recent Bybit attack, and it uses EDS in the background. So check it out, the GitHub. All of this is public. I'll just quickly go through why it's good actually for the execution clients. Because one of the problems with the EIP-7784 is that it requires execution clients to store data in a very specific way. So you have to think of that you have a bytecode and you have accounts, and that's a different things, and that was not an assumption before. However, like rough estimates are that it's going to add some like 4 gigabytes to the index. But contracts today, actually, if you think of them, that's a big thing. They all reproduce, like if you deploy the ERC20 token today, it will be the same code deployed to different addresses, added with like small metadata behind, which makes like the hash different. Hopefully you have changes that, but with this EIP, you just have a pointer. So you have one contract which once figured out how to do that, and then if you want to deploy another one, you just make a reference. That's it. It's very easy and simple. And then it also actually provisions solutions for one of the long-term problems with Ethereum is that bytecode cannot be pruned. You can prune the storages or event data, but bytecode is not really prunable at the moment. But if you have an index, you can actually get the metrics of how often this code is being used for anything. And well, at some point, you might want to put in an archive or figure out some pruning solution to that as well. Yeah, I think that's pretty much it. Thank you. There are my email and my Twitter, and I think we have time to some questions.
Yeah, we can have some Q&A. So does anyone has any questions? Oh, here. Wait, there's like a microphone. Okay.
I'm seeing this proposal very good, wonderful, I love it. I'm just wondering, is there any drawback or disadvantage that might be introduced because of this approach?
The only challenge I see is that execution clients have to store data differently than they assumed previously. I cannot see any particular disadvantage for anyone. There is one security assertion you have to keep in mind with ERC-7784 and this one as well, is that the first time the contract gets indexed, it does, some particular actor does it. So they might have their own storage logic there, and you cannot really refer to the security of that as like doing calls to that contract, but you can, it's your responsibility to attest to like check the security of that you actually want to use that code. Beside that, I think it's all fine.
Got it. Thank you.
Okay, so maybe one more? Anyone? Okay. Then if not, let's give Tim a round of applause.